All right, guys, ready for liftoff?
Yes, we're ready. Please count us down.
10, 9, 8, 7, 6.
All right, get ready, boys.
Start. 2, 1. Booster ignition and liftoff of the Space Shuttle Discovery, returning to the space station.
Oh my god, Nick, do you feel that? Yeah, what is that? I think the engine's failing. No, Nick. Nick. Oh, Nick.
Yeah.
What just happened, dude?
I don't know.
Try to get up. You good? Dude, I think the rocket just shook like crazy. Get up. Get up. You good? Yeah. Dude, try to call back to command. See if they can help us. Is anyone there? Yo, hello? Hello? Anyone can hear us? Damn, I think we're stranded. Nick. No. I think we're stranded. Yeah, are we gonna die? No. Nick. Mommy! No! Daddy! No! You get up. Okay.
Gotta save myself from.
Dude, what do we do?
Yeah, jump.
Oh, damn. All right.
You ready?
Okay. Ready? You go there, go here. Ready? All right. See you in the afterlife.
Here's what we know. After you jumped out of the rocket, you landed 150 and 90 feet away from it. You guys are 210 feet from one another, and we need you to get back to each other and to the rocket so you can climb inside and get back home. But we'll need to find the angle of elevation you see the rocket at so we can find out how tall exactly the rocket is. We'll start with our 150-foot astronaut. And I think we can use law of cosines to solve this, but first, we're going to have to solve for our top angle right here. So let's begin. C squared is equal to a squared plus b squared minus 2ab cosine of c. Plug in the values, we'll get 210 squared is equal to 150 squared plus 90 squared minus 2 times 150 times 90 times the cosine of c. Simplify it further and we'll get 44,100 is equal to 22,500 plus 8,100 minus 27,000 cosine of c. Now let's add. 44,100 is equal to 30,600 minus 27,000 cosine of c. Subtract 30,600 from both sides, and we will get 13,500 is equal to negative 27,000 cosine of c. Divide both sides by negative 27,000, and we will get that the cosine of c is equal to 13,500 divided by negative 27,000. To find the measure of angle c, we'll do the inverse of cosine c times 13,500 divided by negative 27,000. And we'll get that the measure of angle c is equal to 120 degrees. Now we'll use this information and find your angle of elevation, astronaut. We'll use law of cosines again, but this time we'll do b squared is equal to a squared plus c squared minus 2ac cosine of b. Plug in the values, we'll get 90 squared is equal to 150 squared plus 210 squared minus 2 times 150 times 210 cosine of b. Let's simplify. We'll get 8,100 is equal to 22,500 plus 44,100 minus 63,000 cosine of b. 8,100 is equal to 66,600 minus 63,000 cosine of b. We'll subtract 66,600 from both sides, and we will get negative 58,500 is equal to negative 63,000 cosine of b. Now we'll divide both sides by negative 63,000, and we'll get that the cosine of b is equal to negative 58,500 divided by negative 63,000. We'll find the measure of angle B by doing the inverse of cosine. So cosine B, negative 1 times 58,500 divided by negative 63,000. And we will get that the measure of angle B is equal to 21.786789. But we don't need to be that precise, astronaut, so we'll just tell you it's 22 degrees.
Ivan, where are you? Hello, Ivan? You there? Ivan, where are you?
Hello? Yo, hello? Who's that? Yo, Nick, is that you? Hello? Nick? Hey, where you at, Nick? Hello?
So, now that we know that the top angle is 120 degrees, we're going to have to try to find the angle of elevation of the other astronaut. And for that, we're going to have to find each individual measure of the top 120 angle. So, to start off, we're going to find the angle on the right. So, we're going to do 180 minus 90 plus 21.78678893, which is the angle on the far right, and also the angle of elevation of the other astronaut. And we get that the top angle is 68.2132107. Now we're going to do 120 minus 68.2132107 to find that second angle, which turns out to be 51.78678893. And then we're going to do 180 minus 90 plus 51.78678893 to find that angle of elevation of the second astronaut, which turns out to be 38.2132107, which we also round to 38. Now, finally, we're going to have to find the height of the rocket. So for this, we're going to use law of sines. Sine B over B is equal to sine A over A. We know that B is 22 and A is 90 and uppercase A is 150. So we're going to plug these values in. Sine 22 over X is equal to sine 90 over 150. But then we cross multiply and we get that X sine 90 is equal to 150 sine 21.7867893. Then we're going to divide both sides by sine 90, and we get that X is equal to 150 sine 21.7867893 over sine 90. Then we get that X is equal to 55.67306168, which we're going to round to 56. And to get our final height of the rocket, we're going to add 5 to that entire value, and we get 60.67306168. And we added 5 since each astronaut is 5 feet tall, and we get that the final height of the rocket is 61 feet.